So on this problem, we're going to be using, now if you do it one way, we'll be using the sine and cosine substitution. We could potentially use Pythagorean identity substitution in a certain case, which in more or less it will kind of be forced to go into that. It looks like we don't have any evens and odds in this particular problem. The reason why there's no negative signs in there, so I don't have to worry about that. I'll try to give you an example today where we're going to use negative signs in a problem. We'll try to see one of those today at least. But this is kind of the idea today that I want to go through. I want to try to give you a couple examples of kind of a range of different style problems. I have 2 or 3 picked out. We'll kind of see where you guys are comfortable with. And then it's going to be kind of some group work where we try some different problems out. You can work in groups to try to figure them out. I am going to have you guys hand in your group work papers today. Now I know you're in different groups today. That's fine. If one of you still has a paper from yesterday, you can just use that. Just turn it over. But I want to give you at least some points for attempting to try out some of these problems today. You know, for an attempt. They don't have to be perfect. It's our first couple days. But let's talk about this problem. Now yesterday, I don't know which form you guys wanted me to do. I don't know if you guys wanted common denominators or to do substitution. I forget which one we did.
Both. Let's see both.
Okay, we're going to do both, but I'm going to do both. I just didn't know which one we started yesterday. Question?
Do you ever test it?
Yeah, but we can't get it back because we saw people taking it. So I will have the scores.
It's done.
The scores will be entered today, so you can see what your score is. But we're going to talk about it at a later date because we have to make sure everyone takes it before I
Around what?
So the scores will be entered. So they'll be entered probably by 6th period today.
6th period day?
So.
By 6th period or after?
During 6th period.
During.
I'll say. The reason why is that I'm not going to wait any longer. It's already been too many days anyways. The test has to be done today anyway. So I'm going to grade it no matter what. So, alright. But anyways, for this particular problem, let's do it the first way. I'm gonna do a quick sine cosine replacement here. So on tangent, this is how I'm going to deal with this. I'm going to replace tangent with the fraction that's equal to it. So I'm replacing tangent on the bottom with the fraction, which is this. This is one of our first rules that we had, that anytime you have tangents, cotangents, secants, cosecants, replace everything in terms of sines and cosines. So if they're fractions, replace them with fractions. So I'm taking out tangent squared and I'm replacing it with sine squared over cosine squared. I know that seems a little silly. This is one way you could do this problem. It's one way. So you get to this. Now I know it looks more complicated, but the reason why this is actually useful is because when you divide this top by the fraction on the bottom, you can actually just multiply it by its conjugate. You can take the top times the reciprocal of the bottom. I don't know if I said conjugate, but I meant reciprocal. You can multiply by the reciprocal of the bottom. That's the same as dividing by whatever the bottom is. So this is just this fraction by itself. I still have the 1 minus out front, but this idea back here, I'm going to multiply these together. Now if I were to multiply these together, this is over 1. What happens to these diagonally?
Cancel.
Yeah, these are gone, and I'm left with cosine over 1, which is cosine squared. Now, the goofy part was earlier, this is sine squared over cosine squared because it was tangent squared. So if you have tangent squared, it's sine squared over cosine squared. But anyways, when I multiply by its conjugate, these simplify, and this part is a Pythagorean identity.
Sine squared.
Yeah, it's sine squared. If you didn't recognize it, it's right here. It's sine squared plus cosine squared equals 1. You can do any manipulation of those, where I can move cosine to the other side and subtract it. So 1 minus cosine squared is equal to the sine squared that was on the other side. And that was the answer I was looking for. Like, we got it down to one single trig function.
So wait, what is the answer? Is it sine squared or is it 1%?
This. That's the final answer. But this is what we had to get down to. We had to get down to this. Now, it didn't matter which form we did. We did it this way, where you actually replace tangent with sine and cosine, which is kind of easy. Or if you did common denominators. I don't know if we did common denominators yesterday. I'm going to show you that here in a second, just to show you it would get you to the same answer. It might look goofy, but it would still get you there. Okay, questions on how I simplified it the first way? That's just doing a sine cosine replacement, and then eventually it got down to a Pythagorean identity, like I said. All right, but let me do it the second way, the second style, because again, a lot of these have multiple ways of doing them. That's why I kind of like these.
What was this one called?
That was sine cosine replacement.
Number 3.
So let's go to the second method. Okay, so same problem. Sine squared over tangent squared. Okay. The second way of doing it is if you went with common denominators right away. So I'm going to make this 1 to be 1 over 1 because you have to make it a fraction. And then if you're going to subtract the fractions, bless you, we have to get common denominators, bless you again. So that's tangent squared over tangent squared. Sine squared, tangent squared. All right, now, the reason why I can do this, if it's 1 over 1, you can put anything on the top and bottom that you want as long as they're the same. This divides to make the number 1, so it's the same thing. Now that I have this, I can actually subtract straight across. So I have tangent squared minus sine squared all over tangent squared. Because when you actually subtract, you actually have to have common denominators. And if you do, you can just subtract the tops. Okay, questions so far?
No.
Now, at this point, I'm right here now. I would probably, since it looks like it's not going anywhere, it's not getting simpler, or more simplified, I should say, not simpler, but more simplified. The idea is that what I would probably do at this point is I would do a sine cosine replacement, just because it should hopefully help you get rid of things here in a second. So I'm going to replace everything in terms of sines and cosines. So this turns out to be, I'm just going to continue up here. This is sine squared over cosine squared minus sine squared all over sine squared over cosine squared. Now, if you did it this way, we have complex fractions. You can try to add the top together, or subtract the top, I should say, which there's fractions up there, so I'd have to get common denominators up there as well. And then you choose to do a reciprocal. Now there's two ways you can do this. I'm going to actually show you the easiest way of doing this, just so you can see what this simplifies into. But here you go. So watch this. So this is the way that I would do it, if you noticed it. I would choose to just multiply the top by the reciprocal. The whole thing, whatever the whole top is. That's sine squared over cosine squared minus sine squared. I'm going to take it times the reciprocal of the bottom.
Cosine squared over.
Yeah. And when you do this, when you multiply, it will distribute through the top and it will simplify things. So you're allowed to multiply this to this fraction, which what would happen is that everything would simplify because it would be sine squared cosine squared times cosine squared sine squared. And yes, those will simplify. And then the second part, I'll take times cosine squared sine squared. Because again, how I'm writing this down, I just handed out this cosine squared sine squared to both items. And that's what you're seeing here. I'm multiplying by the thing that I just distributed. And what happens here is that these all cancel out, so I'm left with 1. Over here, the sines cancel out, so I'm left with cosine squared, which is the same problem I did earlier. Now, obviously, this method took longer than the other way, but it got down to the same thing. That's why I put a box around it. It narrowed it down to the 1 minus cosine squared, which you had to recognize was a Pythagorean identity. There's 3 Pythagorean identities. There's this one. There's the one with tangent squared and secant. You can see that one, it's right below it. It's tangent squared plus 1 equals secant squared. And then there's the other one with cosecant and cotangent.
Yep.
So these are the 3. Now obviously, my method, when I always do this, when I always try these problems out, I usually try to do sine cosine substitutions first. I don't know why, it's just a little weird quirky rule that I do personally. It doesn't make the problems any easier. It's just something that I've been ingrained, like that's what I always start with. You don't have to. You can, if you're really good at factoring, or if you're really good at, doing this whole thing where you get common denominators and stuff, that might be your style, and it will still simplify. Now, the cool part about your homework today is that they actually tell you what you're going to get down to. You just have to show that it's going to simplify into that, and you're actually trying to show like the minimum steps, like 2 or 3 steps that actually shows you that the answer should be sine squared. So they're actually telling you what your answer is in your book. That's the nice part about this. So it's kind of cool that they're actually telling you your answers, but you just have to show that it gets down to that.
How do we do that?
So, okay, I'll show you an example, okay?
Okay.
All right, so let me pick out another problem here.
We're not gonna do the packet problems.
Yeah, we're gonna do the packet problems here in a minute, but I want to show you another one that would be like your homework, which will be in the packets.
Can we see multiple ways to do it?
Yes, if you need to.
Yes.
Okay, well, let's do a problem here, and then we'll get to the packet stuff where you can try some out. But I gotta get through at least a couple examples, so you're kind of well aware of what you have to do.
I have a question.
Yes.
Who's the sub?
She's gone now.
Good question. I knew it about a week ago. I had to look.
About a week ago. I woke up. We need you to let us know.
I'll look at it.
I think that should be
All right.
priority one.
Here we go.
Priority mail, flat rate.
Okay.
It's in cheap for a low flat rate.
All right. Here's the first example that I want to do today. And this one has one of the new properties that I want to discuss in it. Now, this problem can be done a bunch of different ways,
Flat rate and stuff.
but this is what your homework will do.
CX.
That's secant and cosine. Oh my gosh, we're so right.
This is what it shows you. It actually shows you what they want you to simplify it into.
I have a question.
So,
Why are the
this- Sorry. All right. They actually show you what they want you to get down to. So that's kind of nice. You already know your answer. You know that I want to get down to sine minus cosine. It won't go much further past that. So to get there, you always choose to work with the more complicated side. This is obviously the more complicated side. And you could do it by any method you want. We could do sine cosine substitutions, because you replace everything with sines and cosines where you put fractions in there. Or you can choose basic rules of math, like in algebra, to simplify this. I'll show you this 2 different ways so that you know how to do it.
Cosine negative theta.
Okay, so on this, yeah, we'll probably need to pull out this negative sign here because this cosecant is one of your even and odd functions on your property sheet. So if you look at cosecant, the negative sign actually comes to the outside and becomes this.
We're not in a country we can talk.
What is this octagram? Fishing?
Okay, is everyone comfortable with how I just pulled the negative sign out front?
Yeah.
Because that's substituting that cosine, the cosecant with a little negative sign. It can go to the outside because it's an odd function. Now, one method of doing this problem. I'll show you 2 different ways. One method, since this is one item on the bottom, it's not a binomial. This is one item because they're being multiplied together. You can do the rule of division, the property of division that you learn in like elementary days. Whatever's on the bottom, you can just divide each item by it. You could do it that way. That is literally one way you could do this. So I could take the top, which is secant x, and divide by the bottom.
I'm just trying to let you know.
So it's gonna be
Okay.
cosecant, and it's gonna.
No.
And then over here, the second
High
item,
five.
I'm going to divide by whatever's on the bottom as well, which is secant x, cosecant x. So this is one way you can do this by just following simple division rules. Some people probably would never see that.
I get it.
It's fine, you wouldn't have to do it that way. But when you do this, what happens here, these simplify, and I'm left with
Oh.
1 over cosecant.
That's a sign.
That's the front part when those simplify. And over here, the cosecant simplify, so I'm left with 1 over secant.
This is brilliant, Mr. Ward.
And then what you can do is you can look at your property sheet and then do your sine and cosine substitutions. Where if you look at your property sheet, 1 over
Sine.
cosecant is sine.
Wow,
It's
Mr. Ward.
cosine.
How
It's like
did
we
you
got the
figure
answer.
that out?
Oh my god.
All right, and that's your answer. So that's one way to do it. Now, some people would never see that. You would never think, okay, could I divide both items? You wouldn't think about the rule that you were supposed to learn in like elementary days. The other way to do this, you could have replaced everything in the beginning, everything, with sines and cosines. Okay, everything. And then you get common denominators, subtract across, and then you do that whole reciprocal rule like we did in the first problem today. Everything will simplify and you'll be left with that. It should come down to this,
So that my pencils don't get.
which simplifies.
Is there another way to do it?
Other than that,
Yeah.
This is what is on my calculator.
There's gotta be
When I
multiple
roll it
ways.
out of my bag.
Let's figure
Is
it
it a
out.
fire
It's
alarm?
negative
Ramen.
8 times divided by
That's a
Roma.
Is it what?
wireless.
21 or 2 log.
I'm just gotta be another way. That's just, those are the two that I know for
I don't
sure.
want to say this for
Okay,
fire alarm.
hey.
8 equals.
Here's my question. Do you guys want another example, or do you guys want to try some of the pot? Example.
Sure,
Okay.
I'm not comfortable with the negative sign, we need the example.
One more example.
We should maybe do 2.
Okay, all right, here we go. One more example.
I don't know if we're ready for it.
What are you doing?
Can I hit the enter sign?
This is homework.
169.
Broke some metal hook. All right, here we go.
I put my hand up.
Yeah, I was.
I didn't think it would actually
Gigantic. Did you have one in something 60?
Okay, here we go. Last example that I want to go through today. Okay, here we go.
What?
What are you talking about?
Lars.
What?
Hi.
Is you a woman?
You can't want to insult me.
Oh god, there's another negative sign.
Is this the same
I'm not
thing?
sure
Oh,
how
boy.
comfortable with these negatives.
I
We
bet
have theta and an X.
Oh no.
You can't.
This is intense
That's
stuff.
illegal.
This is a brain buster.
Okay. This is by far like one of the furthest problems later in the book that I saw that it was probably the more challenging type of problem. It's got everything. The reason I picked this one, you guys wanted a problem that had negative signs in it, so I picked another one. All right. So on this particular problem, again, we were trying to show that the more complicated side is equal to this side. So you kind of know what your answer needs to be in the end, or what you need to get down to where you can stop. So that's kind of nice, to kind of telling you that. So it's not just throwing you in the deep end today where you're trying to figure out what the final answer is. You kind of know what you can stop at.
Can we switch bonds to candies?
Okay, not yet. Okay, all right. Okay, so down here, I want to get rid of the negative sign out of the sign because it's an odd function. When you put a negative sign on the inside, it puts a negative sign on the outside. So it would be this.
Oh, that makes sense.
Yeah. So when the negative's on the inside for sign, you can put these to the outside, which would make it positive. Because these two negative signs here would actually cancel. So this is what we have so far.
Wait, how did we do that?
You just pick this negative shine out.
The negative is what's really throwing me off.
When you have odd functions with negative signs, sign is considered an odd function when you look at your even odds on that property sheet. The negative sign can go to the outside. If it's an even function, the negative sign would just cancel out. What was that?
Why'd you
Why
end
does
it
that
there?
help us?
Because it makes the negative sign out front go away. And so now we have a very simplified problem where there's no negative signs on the inside.
But last
Sweet.
time
But
we
last time
wanted
it
it to be
just
negative.
kept it negative.
Yeah, well, there was a negative sign already. So when I kicked out the negative sign, it was double negative.
Yeah, but last problem.
Is this called the gauntlet?
Yeah.
This is the gauntlet chapter.
So, yeah, I mean, it's just depending on what the negative sign is. If it was positive, it would stay negative. The
So we
negative.
never want it on the inside.
Never want it on the inside.
Okay, that's
Never.
what I mean.
Okay,
I
sorry.
need to write down the
I must have
board.
missed-
Never on the inside.
Okay, I don't want the negative sign on the inside. I want to get rid of it. All right, so now at this point, there's only one way you can actually attempt this problem now. There's not another way that I can think of that would probably be easier. What you have to do on this particular problem is you have to multiply by the conjugate. The conjugate on the first fraction is 1 minus sine. And so I'll have to multiply that to the top and bottom, because whatever you do to the bottom, you have to do to the top, because it's over 1 technically. So this is what we're going to have. So I'm going to multiply the bottom, multiply the top. On the other side, you have to multiply the bottom by the conjugate, and multiply the top. Okay, questions on what I'm starting with? Again, the conjugate is it's not the opposite, it's close.
Sit back there, don't you?
Okay, is everyone still following with me here?
Yeah.
Yes.
Okay, now when you do
They're gonna have
this,
common denominators now.
yeah, it will come up with common denominators.
They already have
what
it.
if
Yeah, but we're gonna simplify here in a minute.
Oh.
Okay, I agree, but we're gonna simplify. On this particular problem, since there's ones on the top, you can actually distribute the top, it's not a big deal. If there was like a weird trig function sitting here, I would not do it.
square.
Yeah, so if it's, let's say it was like a variable, like an x, or another trig function like tangent, I would actually just leave those sitting there, and don't distribute it to the top. The reason why is at the bottom, when you multiply by conjugates, the bottom usually turns out to be a Pythagorean identity. That's usually how they always work. So when we actually do this problem, here's what we get. I'm actually gonna distribute the top. So this turns out to be 1 minus sine x on the top, because you multiplied it by 1, so it just stays the same. But the bottom, if I FOIL first, outer, inner, last, the middle terms, negative sign and positive sign, would cancel, so I'm left with 1 minus sine squared of x.
Oh, that's one of the things.
Yeah, which is one of our Pythagorean identities. Now, on the other side, over here, same thing, I'm gonna FOIL, or distribute, however you want to say it. You're going to multiply the top, so it's 1 plus sine x, all over, and when I distribute the bottom, first, outer, and last, I get 1 minus sine squared x, which is one of the Pythagorean identities again.
Cosine squared of an angle.
I'm just getting rid of the parentheses. Alright, so we have this, and yeah, you can replace the bottoms with that Pythagorean identity, which is cosine, or cosine. So, what we have so far is we have this. 1 minus sine x over cosine squared x plus 1 plus, is it 1 plus? 1 plus sine x over cosine squared. Okay, so that's what we have so far. We're going to add and subtract straight across. So if we add and subtract straight across, here's what we have.
Plus. That's just 2.
So if I go straight across, I have what? 2 over cosine squared.
We did this yesterday.
I do, but you don't.
Now I know this seems a little weird, right? We added the top, the signs went away. The cosines on the bottom just stayed cosine because you don't actually have the bottom. So we got down to this, which this item can go to the top and becomes secant squared, right? Secant squared. If you move it to the top, because I want to get rid of fractions, right? A lot of people look at it and go, "Ward, that isn't what you were trying to prove." Okay?
No, it's not.
It's fine. What you can do is if you get to a point you're like, it doesn't look like the top. It doesn't look like the other side.
It's not top.
You can actually, once you kind of got to a point where you're kind of stuck, you can now choose to work with this side, and actually like manipulate, because there's probably something you can do to that part that I put in the box, and hopefully it'll turn into this. And there is something I can do here. So far, this left side here is actually molded into that. What I'm going to do on this right side, because I haven't even touched it yet, I'm going to factor out the number 2, because I noticed that they both have 2's. So if I factor out a 2, I'm left with 1 plus tangent squared. And look at your property sheet. 1 plus tangent squared is an identity.
It's
Pythagorean identity. It's secant squared.
Oh my gosh,
Oh,
that was,
goodness.
this is insane.
And then it works. So when you multiply it by 2, it turns into the thing you need. So if you ever get to a point you're like, God, I can't get these things to look the same, you might just need to just work with one side and see if you can just simplify it a little bit. It won't go very far. Usually it takes 2 or 3 lines. Now this one took me a while because I'm trying to explain everything that I'm doing here. Usually I'll do a lot of this stuff just in my head when I FOIL. I just know what it's going to turn into.
I need to.
But sometimes you do have to write some stuff down. The one thing I want to make sure of,
I don't write it.
because I'm telling you, that they're giving you the answer that they want you to try to simplify into if it actually works. If it doesn't work, you can actually write that they're not equal. You could potentially have one of those. I don't think I assigned any of those because those are really difficult. But here's the thing. What I want to make sure of is never drag things across the equal sign.
What?
Okay, I don't want you to suddenly if you had like a 1 over here, I don't want you to subtract it across the equal sign. Because we're trying to show that they're equal, and you dragging it across, you're saying that they are, and that you're actually trying to solve for x. I don't want to do that. I want to show that they eventually mold into the same thing. I don't know if they're equal, because they may not be. I think the ones I
They
picked,
may not be.
They
You just said that a
potentially
little bit
have,
ago.
but I didn't assign any of
The
those.
real question is, does this apply to non-infinite
So
geometry?
what do we write if they
This is basic
don't
curve.
equal each other? Do we say not equal?
Not equal. I don't think I picked any of those today. I only picked the ones
Are we
that
gonna be
work.
taking a test over this?
What? Yeah, that's right.
Let's do soft puppets.
We always take it just over a few sections, so I
What?
try not to go too far. into
Yeah,
it.
this is hard
So,
stuff.
yeah. Okay, we good? All right. Okay, we don't have a lot of time. In fact,
One more
in fact,
example.
Should we take a rest?
I
Our
think we should
brains are
look how hard
swell.
this
Yeah,
one
our
was.
brains are.
okay, hey, I'm gonna write down the assignment on the board. I know that seems a little crazy. I wanna get to you early here. I wanna get you the assignment, and if we need to, we'll go through one more example. Maybe we just won't do pod work today. That's fine. We can always say that for another day when I get back.
We might.
You also need to know who these sub is.
So,
I don't know if I can mentally handle that.
I know that they're a math teacher, so that's
Oh,
one
is it
thing.
that 4-city guy?
Where's your card?
Is it Jensen?
Jensen?
No, I
Jensen
think it was a
levels?
female.
He was at the game.
A female.
Oh, male?
Oh god.
Yeah, he was wearing a suit coat with a t-shirt. Yeah, he was.
All right, here we go. Okay, here's your homework. Okay, homework today is due Wednesday.
Lars.
Who's that?
understand.
She's not 14. She's not
Okay. Hey, due Wednesday. So here you go. It's page 594. Now it might start on 593. I think it's 594 though at the very bottom. Here's the problem. Okay. Hey, I jumped around a little bit. Try to pay attention to the numbers and what you have to go through. So the first one's 2 through 6 evens. So you're just doing a few of those. Then you're doing 9 and 10, or sorry, 9 and 11. So you got a couple odds, so you can kind of check to see how they did it.
Look at the answer.
Then 14 through 20 evens. And each grouping that I'm picking here is a different style. So it's like sine cosine substitution. Some have tangent substitutions, some have the Pythagorean identity, some have conjugates. 23 and 25. And then the last two problems are 30 and 36. So it looks big and it looks menacing. Some of them are not. They take 1 or 2 lines. And they're easy. They're like kind of the problems you guys did yesterday in that little pod where you guys were done in like 2
Are there any like
steps.
this?
The last 2 are kind of big.
Like this big?
Big.
Or bigger than that?
No, they're like that. That's considered big to me. So,
I'd say that's rather small.
You know what, I'd say that.
all right. Well, there you go. And now, if you want me to do another problem, I will.
Look at my
But I want to
Yes,
make sure that you guys get the homework. Now, again, I'm not here tomorrow. I will have a short
I
video.
just kinda wanna rest my brain.
Yeah,
My
you-
brain is fat.
So, hey,
I think we should get a problem after the resolution.
okay. Tomorrow, I will have a short video. The video tomorrow
How short?
will go through a couple examples of the homework. And then it'll intro what we're going into next. And then you'll have about 25 minutes to work.
So it means that we gone tomorrow, do I have to watch the video?
I probably would. Shoot, because I might give you a homework project too.
Oh.
I